to reach at the maximum height, then we have to add t1 plus t2, divide by 2 and come to the 5 second. Now we directly give, this means we directly give the formula for the time of flight is t, and t is equal to t1 plus t2. Again, the time taken by the body to reach the ground when it dropped from the given height h is given by t is equal to under 2h upon g. This equation is very much familiar, because when body dropped from a given height, then equation is h is equal to ut plus half gt square, where u is equal to 0, means t is equal to under 2h by g. Means the equation is again written by t1 to t2 is equal to t dash square, means t dash is equal to under t1 to t2. This equation is also used to determine the time taken by body to reach the ground if it dropped from the same height. If for the same height there are two routes t1 and t2. We just come on the second part, motion in a plane, that is motion in 2 dimension. In this condition, we very much familiar equation of trajectory, which is given by y is equal to x tan theta minus half gx square upon u square cos square theta. This trajectory represents that the equation of a particle when it projected from the ground at any angle theta is parabolic, because equation is quadratic in x, and the path is path of the projectile is parabolic also. Means for any value of x and y, this equation is satisfied, and we have to determine the value of all terms, time of flight, range, and maximum height attained by the body from this equation, either by applying the equation separately along x-axis as well as the y-axis. That the value of time of flight, range, and maximum height determined by the equations. Then the formula of the maximum height is h is equal to u square sin square theta upon 2g. Range r means the body travel horizon t. The distance is given by u square sin 2 theta upon g, and time of flight of a body is 2u sin theta by g. Now the same equation of trajectory of a body is given by y is equal to x tan theta 1 minus x upon r. This equation is very much familiar also. For given value of y and theta, means if the angular projection is constant and the height is given, then this equation is written as y equal to x tan theta minus x square tan theta upon r. Y into r is equal to x into r tan theta minus x square tan theta, and x square tan theta minus x into r tan theta plus y into r is equal to 0. This equation is also quadratic in x, that is it has two roots again, x1 x2, and the sum of roots x1 plus x2 is given by r, which come out from the formula that the sum of root of the quadratic equation is minus b upon a, which I discussed earlier also. And the product of root x1 to x2 is equal to y into r upon tan theta. Let me consider a simple example. If x1 is equal to x, then x2 is r minus x. I discussed in the figure that if two poles are of the height, same height h, and it is placed at certain distance, and a body is projected from a point with velocity u, and it is just able to cross the two pillars. If the distance of the first pillar from the point is x1 and the second is x2, then x1 plus x2 is equal to r, and this is x1, hence this is also x1. Now again we discuss a general condition which is always asked in the examinations, that what is the relation between h and r, and if h is given, r is given, then how you find the angle of projection. Let me consider h is equal to u square sin square theta upon 2g, and r, which is range, is equal to u square sin theta upon g. We divide these two equations, we have to find h upon r is equal to tan theta by 4. This equation is frequently used for any value of h and r and for any value of angle theta, which I mentioned. Let me consider an example that a body projected from a ground at any angle theta, it travels some distance r and some maximum height h, and find the angular projection, which I discussed from the example. A body projected from a ground at any angle theta so that it attained a height of 4 meter and range 12 meter. Find the angular projection. This equation which we have h upon r tan theta